Welcome everyone. So today is the first release webinar of this FEFLOW A0. It's part of the release May 2023. FEFLOW A0 was released last week, on the middle of the last week. And today I'm very happy to demonstrate some of the latest developments that DHI has been doing in the last months. So for those who doesn't know me, my name is Carlos Rivera. I'm based here in DHI, Germany, in Berlin, and a global product specialist for FEFLOW. So today's webinar will cover multiple aspects. So I would like to really look a few things back into the past, because this will help me to explain you what actually we are developing, what I want to present now in FEFLOW A0. We will have obviously a live demonstration with 5 points I would like to demonstrate. So if we look back into the latest developments of FEFLOW, there are two things that I would like to highlight from this timeline. So in 2015, we have the release of FEFLOW 7, when we introduced the 3D and structured meshes in the software. Basically, we extend the library of finite elements in FEFLOW, initially based on triangles and prismatic elements, now to tetrahedrals, pyramids, and others. In the last release, in 7.5, we start a few steps of model conceptualization. With these two keywords, I would like to move forward, because it's actually the direction where we are focusing this release, and structured meshes and more developments in the model conceptualization. So this FEFLOW A0 release has a number of great features. So by the way, I will keep short the presentation to spend most of the time in the live demonstration. So we start with the model conceptualization. So basically, we have this idea already quite long in the past to go more in the direction of model conceptualization in FEFLOW. Some first thing was done in 7.4 version, and more things were introduced in 7.5. So the motivation of going in this direction basically is, as you know, I mean, I can see the names from the participant list. Basically, FEFLOW requires a super mesh. This super mesh is the either 2D and 3D is the basis of a finite element mesh generation, and then we do a parametrization, run the simulation, and resource analysis. So most of the bottlenecks in this current workflow and today's workflow is, if we want to change something on the concepts which are part of the super mesh, we need to redo a lot of the steps which were done before mesh generation, parametrizations, some information could lose, and so on. So our long-term vision is basically to postpone as much as possible the finite element mesh generation. This allows us to bring this concept of this concept first, building a super mesh, identify and add all the parameters, concepts, rivers, boundary conditions, material properties in 2D and 3D, then run the mesh. So which allow us to go back every time, it's very often, and try to remesh create a new mesh without losing any information from the concept. So this release reveals this direction, because we have done quite a number of things in this in the terms of model conceptualization. So our vision basically is that users should focus on the concepts rather on the technicalities. So we basically try to automatize all these different technicalities, like parameter assignments or mesh generation. The implementation basically consists that geometries now have a meaning. So what we know is a point and could be a boundary condition for a well VC could now be assigned before the mesh exists. So a few ideas before we go to the more in detail to this concept is, so if you look back the previous releases, so we introduced the concept of material regions with a parameter lookup table, which can be linked to 2D or 3D information. So we extended now this to the case of points for well boundaries and observation points. So you can now, before the mesh exists, import your points and then define these points will be well VC, for example, when a specific pump rate. Lines could be discrete feature elements already. You can say, I would like to use this specific flow calculation of low for the flow, so Hagen or Darcy, and then FEFLOW will take into account this information. Other great thing is that most of this information that we create in the super mesh, we later require as a elemental selection, nodal selection, etc. So we can also, during the process, tell FEFLOW, store all these selections because we will need it anyway later on. And this workflow, of course, needs a way to easily move from 2D to 3D. There are a number of workflows in FEFLOW how to build 3D models, so layer-based models, partially unstructured or fully unstructured models. So we concentrate in this part of the discussion on the layer-based, on a workflow which starts from 2D data sets. And basically the motivation here is to try to shorten the journey between building 3D models in FEFLOW from a 2D data set. So we always start from a 2D super mesh. We create a mesh and then add the number of layers, slices, put the elevation data, maybe do a lean-to parameter, and then accommodate the different phases or geological contacts. So we are adding a new workflow, and this workflow basically builds automatically the 3D models and give you the flexibility to decide whether you want to be a layer-based model or partially or fully unstructured model, and start from a 2D super mesh workflow. So what is different now is that you put your elevation data right before you have a 2D mesh. So here, again, you concentrate basically in the concept. So I will take this example later for the live demonstration. FEFLOW will give you access to a new panel, which is allow you to provide elevation data. So we keep some of the rules that we use in the layer configurator, but we also add new options to easily build models. And when you run the mesh generator, as usual triangle here, we run a number of steps sequentially. So we build a 2D mesh, we ask the user how to proceed if there is a slice conflict. So we call this layer resolution dialog, and then parameters are passed into the 3D mesh. So you can go back and forward every time to the super mesh and reveal automatically your 3D mesh with just 2 clicks. The other major focus of this release is handling unstructured meshes. As I was pointed in my timelines in 2015 with the release of FEFLOW 7.0, it was the first time that we introduced unstructured meshes. So we were doing quite a lot of things since that time, but there was obviously a major limitation, which basically depends on non-conformities coming from the geometrical data. So if you import typical data coming from a geological model, or could be any data that maybe you prepare in ParaView or in AutoCAD or S3 shapefiles or any other 3D surface data sets, if this data was not perfectly fitting, so the connectivity between the surfaces was not excellent fitting, so there was a problem, and this problem is called self-intersection. Some of you who has been working with 3D unstructured meshes know this. So the self-intersection was basically a showstopper in many cases. So we want to help you more to build meshes, 3D complex unstructured meshes. So we have been doing internally checking a number of workflows now. And we came to this company called GOD Solutions. It's a company based in France. So there is a technological company developing a state-of-the-art algorithm for mesh repairing, but also for mesh creation, so mesh generation. So if you would like to see more about this or what are up to, you can just visit their website. So we introduced the connection to this technology because they are experts in meshes. We are experts in groundwater modeling. So let's try to use the best of these two worlds. And we build this connectivity through a new module. So we introduced a new module called FEFLOW Advanced. This is a module given as what we call SMA benefits for FM3 licenses and FMH3 licenses. So this module allows you to call these routines of GOD for repairing any improper 3D data. This improper 3D data could be triangularized surfaces or surfaces in general, and polylines. So if you imagine here these two planes being intersecting some geological contact, so we could basically repair this. So we are not meshing. We have a tool to repair the input data, which builds our 3D supermesh. And the major advantages of this technology is that we can easily integrate new data sets. So if you already have a 3D super mesh existing, which was working before, and now you have a number of surfaces that are not fitting perfectly to the 3D super mesh, you can open the 3D super mesh, convert the surfaces, so add it on top to the existing, and then run some repair tools to check the validity of the whole geometry before we send the data to TechGen for the 3D tetrahedral mesh generation. So the workflow is really simple. So as I say, we introduce a new panel. This new panel basically allows you to repair this. So let me show you a few examples. So the procedure will obviously look all the different surfaces, how we pass it, and we'll make sure that we fix all the self-intersections and improper data inner in the outer and inner faces. And when the data is ready, so this increase us the chances to create 3D fully unstructured meshes, no, like the case that you see here. Okay, so the other major change in the software is related to the way how wells are built in FEFLOW. So we know that in every single groundwater project, we always have wells. So either well VCs or multi-layer wells, or could be wells related to transport boundary conditions. So we identified the problem, and this problem was basically reviewed. So we introduced a new component called Well Manager Editor. And this component is a central location, is a new UI component dedicated completely to the management of well objects. So it's a very simple table, but it's very smart and user-friendly. You can do a lot of operations. You can change properties, create wells, delete wells, and major advantage is you combine a number of flow boundary conditions and mass transport boundary conditions. So for those one working in the geothermal sector, for example, so you could have a multi-layer well automatically being linked to a temperature VC. For the injection well, you have here all the information required for all the wells, well VCs, multi-layer wells, borehole heat exchangers, flow, mass, and heat transport boundary conditions. You can add the wells from selections imported from a set of points. So we have a number of routines to evaluate or to run neighborhood relationships. Here, it's not just as a table, also this verified auction runs a number of checks which are not available in other parts of the FEFLOW code, which basically we evaluate if there is no conflict between existing boundaries or of the elevation of the well maybe is above or below the topography. So these are the basic examples, but there are a number more of checks. So it will help you to automatically check all this. What I like personally here is obviously wells could be linked to a time series. This search functionality is really nice. So you can look and search for strings, alphanumeric, and you can look for example, for the name of a time series being related to a specific well VC or to a number of wells, multi-layer well VCs. So this is something that you could have done in the past, exporting, importing, and doing a lot of things in Excel. Now you can just simply type the string and the FEFLOW will sort this number of wells. So we move more also in the direction of cloud parallelization. So there are a number of changes done. So some of you maybe have already seen this new panel in the previous release. So we are improving this. So we have a cloud simulation panel, and this panel basically connects the typical groundwater modeling desktop application with cloud resources. The DHI has been invested in the last years a number of development resources to move in this direction in the cloud, with the main objective to minimize the user intervention. So what we are offering you here is a tool that you have, or a panel that you have in FEFLOW. This panel will give you a number of virtual machines. So we have 6 or 5 VM configurations. You can choose these configurations. The VMs will be initialized from our side, so you don't need to really take care a lot of in the maintenance or even have an account in Microsoft. So we will do this from the back side. You can run one FEFLOW model for one VM. If it's a small one, if you take a large VM with a lot of CPUs, you can run obviously more than FEFLOW models in parallel. And if you have a FEPS calibration or uncertainty analysis project, you can connect a number of VMs to the run. There is a lot of advantages. It's very easy to use. And second, you don't need to maintain the hardware on your own. The whole concept works in a credit system. And so you need to have enough credits to start the simulation. So we are connecting this infrastructure to what we call My Cloud subscription. And you just need to define your FEFLOW project or FEPS project, and we will start the run directly from the desktop application, take care of everything. In FEFLOW, you are used to look results in parallel during the run. So we also have a set of charts called cloud charts, where you can look from your desktop application what is happening in terms of the time steps or hydraulic head to concentration values. So basically the different charts that we typically use in FEFLOW runs. We do have also other improvements, so a number of improvements in FEFLOW and FEPS. So because of the time, I will only list and concentrate in the major improvements. So if you want to look in detail what has been changed in the software, I will obviously point out to the online help documentation for FEFLOW. So let's go from the first part with the selections panel. So everyone working with groundwater modeling in FEFLOW is used to work with selections. So selections are part of the workflow, elemental, nodal, phase, or edge selections. And these selections could be the list could be really long. So it's quite tedious to look for selections and then identify which is the right one. So we introduced in the last release a way to drag and drop selections to have a different order, but still it was not completely convenient. So now we introduce the functionality to search for selections. So you just type your string and then FEFLOW will tell you the selections available with that string path. We have introduced a new number of keyword combinations, so to actively and interactively work with selections. So you can add multiple selections with a number of keys, so that you don't need to always right click and then use add to selection. So that was quite confusing and also not very efficient. We also have the possibility to split existing selections. So to give you an example, maybe you have another selection with 10 wells. So you will like to split the selection in individual wells. So you can just now right click and then store the current selection as one selection per item. It's called the option. In terms of FEFLOW and Python interfacing, we see a lot of usage. So the FEFLOW community is moving quite strongly with the use of FEFLOW and Python. So we have a self-paced course related to FEFLOW and Python introduction, and the number of participants is really increasing exponentially in the last months. So we are continue supporting and extending our functionalities in this aspect. So we support now additional versions of Python, so up to version 3.11. So it doesn't matter if you use Python from the FEFLOW GUI, from the scripting manual, from the console, or from a Python interpreter. So we will give you access to these options. Also in FEPS, if you are doing a calibration with the FEM document being connected, or where a script is attached to the FEM, we will also support these different versions. Loading external packages also was an issue in the past. So now if you, for example, run FEFLOW ATC from the console, there is an argument to load the packages in the runs or install the packages. So basically you will do a pip, ensure pip, and then you could install some packages which can be used later as well. And this is available as well from the console run. We have also, as I mentioned, a number of minor improvements and several bug fixes as well being considered in FEFLOW, in the FEFLOW GUI. In terms of FIPES, because we are going more and more in the direction of parallelization, so we thought it's really the time to improve the usability in terms of the way how the parallelization is done. So we update what we call parallelization status panel in FEFLOW. And in this parallelization status panel, basically you could now control the CPU and the memory consumption. So before was really not, was obviously possible to double check through the task manager, but if you want to look for a worker that is not your local host, you will need to connect via remote desktop or to use the terminal to basically look for the CPU and see whether the number of workers in this machine is enough or was insufficient. So now we do it directly from the FIPES GUI. Nicely, what I personally like a lot is this option to add workers. So on the runs, if you realize that you have not used 100% CPU and you would like to, you can select the machine, in this case, the local host, or could be external as well, and then add workers and just typing a number, basically FEFLOW will introduce new slates of workers to the run on the fly. So that is really, really handy. And I like it I find it quite practical. Another thing is in terms of charts and visualization in FIPES, as you know, so we need to create some names of parameters and observations. Basically here I will be talking about observations. So observation names require for PES. So the observation names, they were shorted because there are some rules how to create these names. And sometimes it was hard for the users to make the link which observation name or PES observation name was linked to the real observation FEFLOW name. So we have revamped and reviewed the way how the charts are displaying the information, so which is more user-friendly as well. We introduced also a number of minor improvements for the PES IES optimization. I will show you the live demo about this, and also some bug fixings as well. And with this, I would like to move to the live demonstration. So for the live demonstration, I will start with the first exercise, which is related to the 2D super mesh conceptualization, and also building from 2D data sets to 3D. So the super mesh looks familiar for you. You have already seen this maybe super mesh view already. So what is new? Let me close this panel here. So we have this new block called extension to 3D. So this extension to 3D, it will allow you to add slices. So I have already, because of the time, prepared a number of layer and slices. So just let me double click on this. So that's the dialog that it comes. So it looks familiar. It's using other FEFLOW instances or workflows. So we need elevation data. We need the field and the interpolation method. So you can define the elevation, either constant, interpolation, or you can make the slices be independent from something above or below. So you would like to add more slices, so you can basically use this option is called duplicate slices. So you can introduce the number of slices, and FEFLOW will basically copy or clone the settings that you have and use it for the model construction. Slices could have a class, fixed and movable. This is exactly what we have in the layer configurator. This is because we need some ways to understand how do you want to handle cases where the slice intersection happens. Okay, so obviously you need to assign parameters here. So we enable now this entities panel. So you can go to the entities panel and then define different properties. At the 2 level, these properties are super mesh properties. So we can control the super mesh properties from the panel itself. The properties can be also connected to linked to lines. So if I choose a line, I could say I would like to create a selection. What is the name of this and what is the DFE? And if I activate the DFE, it will give me the law to be used for the calculation. I just keep it simple. And then, so there is no 3D mesh, nothing being built. So I only have a super mesh view here. And as I will start the typical workflow, run the mesh generator, and then the mesh is built in 3D, in 2D, and then FEFLOW creates or interpolate the data. And then on purpose, I have created some slight intersections. So I will be able to call this layer resolution dialog, go to OK, just keep the simple approach of fixing the minimum thickness in those cases where there is layer pinching. So let me reduce this and clip the model. And what is happening is FEFLOW has built all these different material properties based on the 2D information that I have already assigned. The 2D properties, I forgot to mention, they were linked to a material lookup table. So I could assign some values. So don't look the numbers, I put some dummy values only for demonstration. But I said now that I have already the 3D model with the parameterization. I don't like this mesh, so I could close my 3D view and then start from the beginning, remesh again, or mesh in 2D again. And now I will go for a fully unstructured, remesh the complete mesh. And then FEFLOW will start running the workflow now with the different constraints. Create the mesh, it's almost done. And so when create a mesh, basically it also start using the interpolation methods that we have, because now we have tetraederals or a mixture of elements. So it needs to know where to put the data. And only if you in the settings of TechGen you use the option interpolate, that FEFLOW will pass the data to the output tetraederal mesh. And so the default option is also non-quality mesh, so we call TechGen without a Q switch, which will obviously require later that you do a second mesh operation to improve the quality. It's almost done, so let me. Also, what you probably already noticed, so when we will use the power of the 3D super mesh repair, so this comes with a new panel. So there will be a new panel that is accessible and so now I have built a model and a structure. So I have the parameters assigned, the material regions assigned, and the parameters also will be assigned directly in FEFLOW. Okay, so let's move to the next exercise, which is basically what probably most of you are interested in, this 3D super mesh repair. So I have built a simple model. So you see the plane, I have exaggerated a lot the planes because we basically want to see the process. So we have one single, we call convex halt of the 3D geometry. Obviously, you could have some layers. It's not a problem. There is a number of lines. So we have a number of vertical lines. So this could be some dewatering wells or any well that you want. I was telling you at the beginning that you could easily now integrate new data. So I have my super mesh. Now let me add number of files. So if I need to use what was a BTU, and I have two wells. So I call this one deviated well production injection. So maybe it's a geothermal problem. So I can do a right click and say convert to super mesh element, and FEFLOW will ask me for if I want to set some properties. So let me keep it simple like this. And I add the new well. I show this option is new. It's not new, but it's probably not well known. So so it's always good to highlight these options. And now I have the other one. So let me deactivate again. So you see now the wells deviated. If I put some of the faults, let's put it later because you can see it better. So the well is basically cutting some of the faults. So if you try to mesh this with TechGen, which will not obviously work, will give you right at front the problem of self-intersection. That's easy. So, so you see there is a new panel. It's called Super Mesh Processing Panel. So this panel will be obviously extended in the next release. So we are now intensely continue working for more tools. There are a number of options. So the major two option is you repair. So repair is the first button. Repair surfaces. Basically, we look where the conflict exists and then repair this connectivity between the intersections. So if I take this plane, we'll basically repair it here, and we'll also discard surfaces outside. So that's a way how we decided to implement this inside FEFLOW. When you repair it, it could be that the repair process create a number of triangles or new triangles because it needs to retriangulate. It's up to you to decide whether you go forward from this output 3D super mesh to a tetrahedral mesh generation, or you decide to run a second workflow, what is called retriangulate surfaces. Retriangulate surfaces basically means that we will remesh triangular only the outer and inner surfaces, so then you get a better quality. And the process could take some time depending on the complexity of the problems. What we also introduce, and I like it quite a lot, is this option called generate region markers for each block. For those ones already working with TechGen, so you might know that TechGen requires a point to be inside a closed volume to be able to wrap these elements created, and then FEFLOW is able to use these created elements to build selections. So now we are building these points automatically for you, which is a great thing. So let's run this. So it might take probably if I remember 3-4 minutes. So I can explain you a number of things. So so we have also, when you retriangulate these surfaces, we have a number of methods that we added. So preserve original vertices and segments. So if you really want to preserve the contacts where before import from your data set, so FEFLOW will do that. So we send these signals to GOD, and GOD will do the job following this. So we also need a ways to control the quality of the triangulation. So for this, there is an angle. So it's a dihedral angle for facets comparison. So if you imagine you have two surfaces, we try to look the angles between these two, and that is the surfaces. So you see that the repair process is quite fast. It takes only 0.2 seconds. No, here, repairing surface is 44 seconds. This is quite fast. So the model is actually not that small. So it's about 5 by 10 kilometer size, and the surfaces are pretty much complex. So, and the other parameter to control the quality is the target segment length of triangle. So if there is 0, which is default, basically means we look what is the average size of the elements, and then we use of the triangles, and we use this as an input value. But obviously you could control this process or this parameter. So you will need to do some trial and error and see what is the quality. Smaller values will create more triangles in the outer faces, and then we'll obviously later create more tetrahedrons at the end of the process. No, so the heavy part of the job here is what is taking most of the time is building this super mesh. So we have repaired it, but we need to build again this new connectivity. So we are replacing the super mesh on the fly, and this is what you see now here. And this super mesh has a new triangulation, so it has corrected this angle, these intersections here, and has done the job here. You see the faults. So let's try to mesh it. So let me put some values here. So to control the quality, so I'm saying I'm controlling the global tetrahedron volume in TechGen, to telling TechGen that don't create approx tetrahedron elements with a volume about this number. So there are different ways to control the quality or the size of the mesh. So this is one of the parameters. So the process run straightforward. You see, I can read in my log panel TechGen generated, and that's the mesh. So result of this auction being generate region markers is the block. So I have the different geological blocks which are between the faults. So these are the different blocks. I have the surfaces, so I can show you also in parallel the other Development, so if you hold control, then you can activate multiple surfaces. And so we can look the surfaces here. So if these surfaces are supposed to be fractured, so you can right away go to discrete features and say Darcy, and FEFLOW is going to create this. So let me put it here in the view so we can take a look on the surfaces. This is the surfaces, and the other part, so we have two lines being intersected. So basically we have corrected deactivate this. We have corrected the intersection of the polylines with the two planes. So there is a point here on each side. Let me call this injection. So we have it slated, and we have this one here also has been corrected. If I look at it from the top, I see that the polyline cutted two surfaces and also correct that intersection. So that will be a production one. So that's the output of the tetrahedral mesh, no, the repairing. So if you would like to try different settings, so you need to go to the super mesh and run the workflow again. So, but let's leave it like this because we need to move forward with the time. And the new option regarding to the wells is called a well manager. You use this well manager from the edit well manager or control W view. It will open the well manager. It's a tabular view. The well manager will be used for creating a number of wells. So let's add wells here. So I will do an import. I have already prepared. So we support a number of file formats. We are extending this list of file formats in the next releases. So I use a table that this has a number of wells here, 54 wells I can identify here. So it's a pump race, some numbers. Then I will verify and see what's come out. Seems to be everything okay, it's in green. Now let me change this value by something very big, and then verify, and then highlight the value, the well, and tell me the coordinates are outside the mesh domain. So I could decide to correct it, or let me delete this. So that's one way to create and creating now well VCs. So let me take the wells that we prepared here. We have an injection well, and in this injection well, it will be a multi-layer well, so I can add multi-layer wells from selection. One click, and then it's added on the bottom. So we can give a name, injection, and then say this will be negative 500 cubic meters per day. And we have a production again, and this will be production. And we can use 500 here. You can, if you change the proline class, so to a heat, you will be able to set also a temperature boundary connected to the injection well. But let's keep it simple. So verify again, everything is in green, apply, okay. If I go now to the summary table in FEFLOW, I can see that the wells has been created. I have 2 multi-layer wells and I have 53 well VCs being added into the system. So you can go back and forward and create this well. So what is coming in the future? So hopefully in the next release, so we are opening this dialog to Python so that we can control number of things. We are also activating wells, deactivating wells. So this requires a little bit of reward in the code. So might not be in this release, but maybe in the next one, in 2 releases. And we also want to work with groups of wells, so that we want to have a location where we could orchestrate a number of groups. And look in my list of things to show. And the last, what I would like to show you is FEPS. So if I go to FEPS, I can show you some minor thing that we introduced is, so I have a parallelization, only 1 local host. I could add more 4 workers if I create the files for PES. That's okay, and then run it. So it's deploying it takes a bit of time because it needs to run 1 model, but it's deploying now 4. I see, I could click on that. Now it's calculating the Jacobian matrix 61. I have Yeah, maybe I could use more of my CPU. I can add workers, and let me take 3 new additional workers, and this will be appended into the runs on the fly. So now are there, and the list is updated. So you can now utilize the CPU. If you want to do this from the cloud, so there is a panel under tools, this cloud simulation panel. This panel requires a login, so you need to have access. So per default, you will not have access, so you need to contact support to we can give you some access and check the validity of your credits if you have. And with this, I would like to finish the live demonstration. So if you would like to use FEFLOW A0 now, so it's available in our website, as was mentioned that since the last week, so you can download it and verify so the different workflows and the new workflows and features in this new version. If you're interested to get new information about FEFLOW, so about features, tips and tricks, webinars, so you might know that we are running a number of webinars every month. Please subscribe to our DHI FEFLOW newsletter, and then you will get the information per email at the right time. So thank you for all these interesting questions. It was a pleasure for me to introduce you today to FEFLOW 8 in this release May 2023. And I hope to hear from you, your feedback. Let's keep in touch. My email address is here, cbi@dhigroup.com. And with this, I would like to wish you a good evening, a good day, depending where you are in the world. Thank you. Bye.